Okay, that's the Darwin implementation. So next, we look at the final section, the final application, which is P2P. And we look at the P2P architecture, which has an evolution, and then look at the P2P performance issue, and then BitTorrent, the BitTorrent, and then the BitTorrent client, which is called Vuze, V-U-Z-E. Okay, here's a P2P. Okay. So the the physical network is this, where you have a peer or a PC. You have two clients connected to the network, and however, they know each other. So P1 and P2, they know each other, so they can, in a sense, they can talk to each other directly. So now they know each other. So the physical topology is this, but the logical topology is this, where the P1 and P2 can talk to each other directly. It's a lot more like they have a connectivity, but in between. It's more like they have direct connectivity in between. So a P2P network is a distributed network where there is a virtual overlay network at the application layer, and the participant acts both as the client and also as a server. So I don't know who are client and server, but because both they act as both client and server, and then when they have connectivity in between, then it's an overlay network. So why P2P is significant compared to the traditional client-server model? Why? Traditionally, only the servers are visible. The client are not important at all. The client are invisible, almost invisible, not important. And the client does not provide content. The client are content consumer, while the servers are content or service provider, right? So two things to characterize a client-server model, where there'll be two things. One is the servers are visible, clients are not. Secondly, is servers are content providers, while clients are only content consumer. And thirdly, the connectivity is only between client and server. The server is passive and the client is active. So the connectivity is between client and server, but no connectivity between what? Between server and server, and between what? Client and client. Between client and client, there's nothing. We don't know. We don't know each other. The client and client. The connectivity between client and client is really not there. You only have connectivity between client and server. So because of these three things, the internet is quite biased that only the servers are visible, only the servers are providing content, and only connectivity between client to servers, which is a bad, because the servers are administrated, right? Administrated by human being, so they would have authority. So if I'm a client, I have no place to provide my content. Not only the server can provide the content, but the client could provide content too. But in the client-server model, with the client, it is difficult to provide content. So then you would say, okay, I can establish my own website I establish my own website. Then then you become a server, not a client. So then in that age, if you want to provide content, you need to turn yourself to a server. You can provide content if you are a client. Okay, that's the client-server model. But the peer-to-peer model say the client can also provide content and services. Okay, so later on there are people like 无名网站、无名小站，我不知道英文 I don't know how it's the English name. The English name of 无名小站 You don't know? Okay. Okay. They would allow people to post. They have a server, and the client can have a space, a page space for the client. Okay, you register and then you got a space on the server. But still, you become a part of the server, right? Not a client. So in order to, if I'm a client, I want my content to be visible. Either I become a server of my own, or I become a part of a server. Say I open up a web page on a server. I put my content on a server. And the third way, there's a better way, which is the third way. Again, the first way is I become a server, a web server. The second way is I contribute my content to a part of a server. And the third way is that I don't become a server, but I join a network, a P2P network, so that my content on my own client side could be visible. My content could be visible even though I don't put my content on the server. I don't need to post. I just put it on a directory, and the directory is I have tagged that directory to join the P2P network. Then my content become visible, even though I don't become a server and I don't post my content to the server. My content can still become visible. So that's the idea. So when that happens, then the content has been extended. I mean, the scope of content has been extended from server to client. The content stored at the client side could also be visible and accessible by the internet people. Okay, so that's the quite dramatic difference. So they call it the Web 2.0, Web 2.0, and actually Web 2.0 under is the top level. Web 2.0 application are something like Facebook, something like Twitter, those kind of social networking, and also some other P2P application. That's Web 2.0. So the essence of Web 2.0 is that the content could be stored in the client side and still visible and accessible. You don't need to become a server. You don't need to post your content to the server. The contents just stay wherever it is. Okay, that's a Web 2.0. And the technology, to achieve Web 2.0, the technology underlying will be P2P, where the client could be visible and accessible, providing content. In that case, then the client becomes the server. So that's why it's called a peer instead of, sometimes it's the client, sometimes it's the server. So it should be called a peer. And the peer is supposed to be able to provide content which reside on its side. Okay. Yes.
What about if I have 3 participants, like A, B, and C?
Yes.
For example, is it possible, like for A and B, what will happen if A and B demand
Okay.
And while at the same time C is trying to retrieve from B.
It depends on whether they know each other. If A and B and C know each other, then they have connectivity in between. A, B, C, C, A, they have connectivity, right? But if the connectivity is not established between A and C, you have connectivity between A and B and C, then A could not directly retrieve information from C because there is no connectivity yet. So if A and B, for example, if A and B have connectivity to C, so they know what resource C has. But A does not reach B. B does not reach A, so they don't know what resource they have. And usually there are schemes, later on you will see there are schemes that would either try to relay the information. I mean, C will relay the information that B has something that A probably need. Okay. Or they will somehow centralize the information to C. Yeah. Okay. Okay. So P2P usually, because imagine this, when only in the age of client-server model, servers are visible, right? And they all have domain name, and they are searched and indexed by what? By search engine. So search engine know these servers very well, because the server has been there, so many servers, but they are always on, right? So what the search engine does, what? The search engine crawl the server content periodically, continuously. So they have good index about what server had what content. So every time you key in a keyword to Google, it would search the index, the Google server locally, and then you know what server had the content you might need. So that's the server. However, for the client, now the client has content, but will the search engine crawl the client? Would they crawl the client to crawl the content? Will they? Probably not, because the client are not always on. For example, I'm a client. I'm not always on because I will close my computer when I'm off, when I'm going to sleep. So the server, the search engine cannot find me easily. Okay, that's the first reason. The second reason is that I'm not mounted on a web page. As a client, I'm not mounted on a web page. And the way that search engine works is to traverse through the hyperlink between the servers, right? So that they would know, okay, they will reach every server. But for the client, if you are not hyperlinked, the search engine will not find you. So even though you provide content, I have a good content in my PC, and even if I stay on all the time, and I make sure my computer is always on, even when I'm sleeping, the search engine normally would not get into your disk to crawl, to do indexing. So your content is still invisible, right? Then how do you make your content visible? It's unlikely through search engine. It's not like servers. So how? There are several methods, but so the biggest problem usually with P2P means the client the clients are providing content. When clients are providing content, it's a big problem to know who has what. Okay, so usually in P2P, it involves resource discovery and then resource retrieval. And usually resource discovery is much more difficult than resource retrieval, because once you discover the content and then you just retrieve, say with TCP. But resource discovery is then difficult. How do you make your content visible to the other peers? Okay. Okay, there are 3 types of P2P systems. One is centralized, that okay, everyone just put what you have. I mean, not your content, but the index. I would say that I have ABC. I put ABC on the centralized server, but I still leave my content of ABC here. I just put the name of ABC there. I just put the name on the centralized server, which is called directory server, a centralized directory server. And who does this? Who did this? It's Napster. So this is a centralized server. Napster did this, and it was sued, and then closed. And what they did is they have a directory server and encouraging clients to connect over, and then the client program would then report the content they have, the name of the content, onto the directory server. Okay, every client do this. The Napster client program will check your hard disk. And you specify the directory that you want to share. So the Napster client will check your hard disk and then put the file name onto the directory server. Okay, if every Napster client does this, then every client can do query on the directory server to see who has this content. And at that time, it usually is the music song, the popular song. And so you query and then see, oh, that guy has the content, so I would then connect to that PC, his PC, and then retrieve the file, retrieve the music content. So that's the way it works. So every peer does upload the index. Every peer upload the index to the directory server, and they could then later on query the directory server. And once they have found who has the content they need, they would download from the peer. So the download from the peer is not through the directory server. It's direct connection. And that about 10 years ago, well, not 10 years ago, about maybe 6 or 7 years ago, it was a debate whether this is their duty, because the Napster, which maintained the directory server, said that I'm not providing the content. It's my client. It's the client who provide the content. So I don't have copyright infringement. It's the client who has the copyright infringement. But then the court or the judge think Napster directory server is helping the client. It's not conducting the crime, but helping the crime. It's a crime of copyright infringement. So that's why they have a decision that Napster is illegal and needs to be shut down. Okay, so this is when a client needs to join, a peer needs to join to register to the directory server, and then send the list of content they have to the directory server. That's called publish, and then query and retrieve. Query on the directory server, which is called discover, and then they could do retrieval directly from the peer. It's easy to implement, simple, and support keywords search or full text search. But the disadvantage is that it's a centralized server, so there will be performance bottleneck, single point of failure, not scalable, and it's vulnerable to attacks. And most importantly, it would be sued. So another approach is decentralized and also unstructured P2P. It says this, and the example is Gnutella. Gnutella say there's no central server, no publication of shared object. So once you need to ask who has something, who has the thing you want. You are searching for something, resource discovery. You want to find out who has the content you need. Then you fraud. You fraud a query. You send a query and you fraud a query. By frauding, it means I send it to you and you need to fraud it to your neighbors. And your neighbors need to fraud to their neighbors. So there'll be frauding. However, we can't continue the frauding indefinitely. So the frauding should be limited. Limited scope. So probably say you can only drop 3 hops. So 3 hops away. I'm asking a diameter of 3 hops away. Anyone within 3 hops. I'm asking who has this content. So it's limited scope frauding. and if there's a hit, if someone within this number of hops has the content I need, it will reply my query. All the others will not reply my query. Okay. So as you can see, it sends a lot of queries. So when you send a lot of queries, and some of the query will not get response back. So what you would do is that you send UDP. You send a query on top of UDP, so that you don't need to establish a connection, TCP connection first. So just one query, and I don't care if the query get lost. I don't care if the query does not get any response. I don't care. As long as some of the query get response, fine. So that's the query frauding, and some of them would then, if there's a hit, then they will send back the response, and then it would download. Then the download here will be, we establish a TCP connection, and then do the download. However, these clients, they scatter around the network. They probably are on different subnets. So they are not connected directly. They're probably connected through routers. So for them to recognize each other, they need to know each other. So so usually there are on such network, such a Gnutella, initially they will tell you some initial client, some initial peers that you should know. Okay, so I would I'm new to the network, and you have been on the network for you are the existing peer that would help That will help the newcomers. So the newcomer will send a join. So if you are a helper, a peer, that would help the newcomer. When I join, I would know you. Okay, I would, because your IP address has been configured in my program. Okay, and then I would send a join message to you, and then that existing peer would then reply its identity and also a list of its neighbors. So you would tell me your neighbors, the people you know. Then I would know all of them. I would know some of them. So the existing peer will reply its identity and also a list of neighbors. And it may also forward a join to its neighbor. So you might forward my join message to your neighbors, so that your neighbor will probably reply to me. So your neighbor will tell me what he knows. Okay, so I know more peers. So upon receiving the join reply messages from either the existing peer or its neighbors, I would know more peers on the overlay network. So it's more like a knowing more friends. For example, when you come to, if you are a foreign student, when you come to use NCTU, probably before you come, you only know one person, which is the secretary in the Foreign Student Affairs office. Okay, and then when you arrive, you only know her, and when you meet her, she will tell you some other people who she think you might know, you might need to know. She will tell you some other people who she think you might need to know, and then you know some other, and she told you some other people who are also in the same department or from the same country as you. So you know some other people. And these people, when you meet these people again tell you what other friends they know. So in just several weeks, you know probably 50 people already. Okay, so that's really an overlay network that you by this kind of join and reply, you know more and more peers. And when you know these peers, you would if you have known 50 peers and you want the content, you are searching for content, then what would you do? You will send query to those 50 peers, right? However, probably 50 is not enough, because you might need to search on 500 peers in order to find the content, because the content you are searching might not be so popular. So you would need to search on 500 peers instead of just 50 peers. So immediately we will see that there's a scalability problem if the overlay network or the social network or the P2P connectivity network is totally decentralized and unstructured. Because you at NCTU you probably know 50, but 50 is not enough to find the content you need. So that's a scalability problem. So how do you solve that? Okay, then you can add a hierarchy. There's a hierarchy. It says that okay, then it says that frauding is apparently not scalable by just simple frauding. So there's a protocol called fast track. It adopts a hierarchical overlay, where within the hierarchy there are super peer, which acts as a local directory database, which store the indexes of objects shared by ordinary peers. So this is how. So within this overlay network or P2P network, I have this yellow node as the what? As the as the super peer or super node. Okay, and they are centralized directory server for this region. For this region, they are centralized directory server. So everyone within this region know this guy, and they contribute the index into this guy. Okay, but between the super peer, they run the decentralized unstructured approach, meaning it means frauding. They need to fraud so that they know each other. So, for example, initially I only know I'm a super peer. I only know this guy, so I connected to this guy, and because this guy also know this and this, so when it reply, I would know these two guys. So now I have known 3 super peers. So that's by decentralized unstructured frauding. We could achieve limited scope frauding. We could have super peers knowing each other. So then if we have this structure, hierarchical structure, what we can do is that if we have a query, we need to find, I'm a peer here. I need to find the content. So first of all, I ask the super peer I know in this region. And the super peer, it will search, it's a local directory. It's a local directory. It will search the local directory. The local directory here. Okay. It will search its local directory to see if it has the content, if someone else has the content. Okay, if there's a hit, it means that someone else, maybe this guy, has the content. So I would then connect it to this guy. If not, this super peer would then ask, because this guy has already known these super peers already, right? So they can issue the query to these 3 super peer, and hopefully the super peer here will then search their own directory, and then if there's a hit, they reply. Okay, and then and the super peer reply to me again. So by this, it is much more scalable. Between super peers, they are decentralized and unstructured, and they know each other by frauding, limited scope frauding. And within the region, it's centralized. Okay. But the problem, okay, so it's fully distributed, reliable, fault tolerant, no single point of failure. But the disadvantage is that between super peers, they are still frauding, and it's limited scope frauding. So it's scalable, but not scalable enough. Not scalable enough, and still may fail to find content that is actually in the system. So, for example, if someone has the content, and it's connected to a super peer, but that super peer was not known, is not known to my super peer. My super peer does not know him. I'm connected to a super peer. I know the super peer. But my super peer does not know that particular super peer, because he might be that super peer might be too far away, beyond the scope, beyond the limited scope of frauding. So the frauding didn't reach that particular super peer. So it's still possible that somewhere in the system, somewhere in the peer, somewhere in the system, there's a peer with the content I need, but the search does not find the content. Okay, still possible. And the super peer may become overloaded or being attacked. Okay. So apparently, we want to solve two things. One is between super peers. Between super peer, we want the super peer to fully aware of each other, and also between the peer and super peer, we want the super peer to disappear. We want to be decentralized further. Okay, so we want a decentralized but structured P2P network by combining the distributed directory service with an efficient query routing scheme. So here's the idea. I'm not able to finish today, but let me finish this idea, and then we come back next week. Okay. So if you have some content, now you have peers and the content or the object. So what you do is that you have a hash function. The hash function maps the peers and the object to the same address space. Okay, so so for example, we all have we are all peers here, and we have a hash function that would hash us to an address space. We also use the hash function to map the object we have. Suppose I have ABC. I would hash ABC, and then into the same address space. So if the address space is 1250, for example, 1250, I hash myself to my address. I hash my own address to 20. Okay, so my ID in this P2P network is 20. That's my ID. And then I hash my content, which is ABC, and into an address space, the same address space, which is 1250. Suppose that my content A has been hashed to 37. Okay, 37, and my content B has been hashed to 22, and content C has been hashed to 41. Okay, then the content A, I say content A has been hashed to what? Say 27. Okay, content A has been hashed to 27, and one of you has been hashed to 127. So suppose you have hashed to 27. So your ID as a peer, your ID is 27. So I would, and my content A has been hashed to 27 too. So what I do with I would send a register message to you, telling you I have content A. Okay, I put the name of my content in my register message to you. So you know that I have the content A. Okay, after I send you the message. Okay, so if someone wants content A, so say for example you need content A, and you take the hash function to map content A to 27. So now you know in order to find who has content A, you need to ask node 27. So and then you reply, because I have registered to you, so you know I have that content A. So you will reply to him saying, okay, node of 20. Node 20 has a content A. So you know I have the content. So you send me the message to retrieve the content A. So so the key idea is that we hash peers and the content to the same address space. Okay, to the same address space. And and the second idea is that the content provider needs to register the content to the the peer which has the same hash ID, the same hash value. My content A has been hashed to 27, and you have hashed yourself to 27. So we are in the same address space. Peer, your peer, and this is content. Both are hashed to 27. So I would register my content to you, and other people will then would use the same query hash function, so they will know that you are the peer responsible to know where the content is. Okay, so it's fully distributed. So you are I'm the content provider, and he become the contents A's. I'm the provider of A, and you are the directory of A, right? And you are the consumer of A. So you need to ask him in order to find me. So that's the key idea. And you know, in this way, there's no centralized server, right? Everyone is distributed. And the content won't be, the directory is also distributed, because some of the content will be hashed to 27, and they will register to you. And also, your content will register. You have another DEF content. You would register to some other peers. So it's fully distributed. And if one peer fail, fine, just one gone, right? But the problem is, if I hash to 27, but no peer has been, if I hash my content to 27, but no peer has hashed itself to 27, what would happen? What would happen? I hash to A to 27, but you hash to 29, but no one else hashed to 27. Then I can't send it to 27 because no one has hashed to 27. So what I would do is that I would register to the next peer. I mean, no 27, but there are 29. Then I send it to you. So you are responsible to take care of 27. Okay, because there is no 27. You are 29, and no 28, no 27, no 28. Then you are responsible. So I would register to you. Again, you hash the content A and find it's 27, but then you realize there's no peer with the ID of 27 and 28, but there's a peer with ID of 29. So then you would ask 29, right? So that's the idea. So there, and with this, you come up with this. The directory. This is distributed directory with hash function, but you still need it. For example, this. The content is here. I mean, the directory is here. The directory is here, but your hash would probably you probably need to hash several times to look up the table and then finally get it here, because sometimes you hash but no. For example, I hash here, but no one, no peers. So I hash again, no peers. So I move here. But there's one close by. So I check here, but none. If none, then I hash again, but there's no one here. So I check this one. So after several iterations, I might find it here. So I'll explain this next week. But the idea is just what we have said.